Okay, so we're on the third set, and I'm looking at these questions over here, and hopefully you had a chance to look at these things and try them. Some are pretty easy, some are more difficult. I think you probably know by now that the sets can be quite challenging, although it varies from person to person. Some people said they're not challenging at all, I can do all these things very quickly. Good for you, by the way. Now, if you're struggling with these things, that's good. Looking at them, I'm going to say probably, easy ones. One looks pretty easy. 5 doesn't look that bad. I think I could probably handle 5 pretty easily. The other ones might take some time thinking about. And I do encourage you to think about what you're given over here. So what I want to do is just kind of look at the solutions over here after I've worked the problems. And these are my solutions, by the way. They might not be the best solutions, but I'm pretty sure they're accurate in the fact that they're giving you a correct answer. Although I may misunderstand something and give you an incorrect answer, and it's open to discussion. I'm not going to say I'm right, you're wrong. That's crazy. I'm going to certainly entertain anyone who says that they think I've done something incorrectly, by the way. And I'm going to say I looked through this. I think I'm pretty comfortable with this. And I'm going to go back to Sage now and wonder, is the machine comfortable with one of these questions? And when I'm looking back over it, I want to point out one of the questions I thought was easy to do was the one in the integration, by the way. Now, granted, you might say, no, the one with the square root of those cube problems was easy to do. I don't know. Whatever one you want to do, I'm just going to go scroll back over the notes and hopefully getting a little better at this. And what I'm trying to do is I'm going to try to type this problem in over here, all right? So let me go to Sage, kind of review what we did in the past, by the way, reset. I'm going to clear the screen first, by the way. I'm going to reset, and then I'm going to type this integration in, by the way. And what am I going to integrate? This thing over here. So integrate. And what are we integrating? We're integrating x plus the sine of x, all right, plus x times the cosine of x, plus sine x times cosine x. You notice I'm using the stars, by the way. Now the comma x saying I'm integrating with respect to x, hit the return, and you get an answer. The question is, you see how quickly it did and how quickly how slow I was at it. I really took a long time to get through that. But I did get to the answer, by the way. And what I get over here, I got the same answer over here. And again, this often is an issue for students looking at this saying, how could that be the answer? It looks so different. It's the same answer, by the way. What do we see here? Half of an x squared, which you see over there. Whoops. Half an x squared minus half of, let's see what I got over there. You know what, that does look a little differently there. Pointing out over here, this does look different than what's over here. And we'll discuss that, by the way. All right, and then you got the x sine x, and that also looks different. And someone says, I wonder why that could be so different, by the way. And I'll tell you the number one reason why. They used a double angle formula to simplify it, all right? So I'm gonna say I didn't put the double angle down for that over there. Now granted, something you could do over here, I'm gonna put bool, B-O-O-L, underscore, double equal sign, and I'm gonna type my answer in, which is what, x squared. You know Sage does not use a constant. They're assuming that you have enough information to know there's a constant there. And let's put this over here, x star sine of x minus the cosine of 2. It's not 2x, it's 2 star x. And that's divided by 4, all right? Now granted, you might be surprised that this is not true because they may differ by a constant, all right? So it says it's false. So someone says, I wonder why that's false. They differ by a constant, by the way, all right? Now, another thing you could try to do, by the way, is differentiate those both and look at this thing. But this is often a confusion using a computer algebra system. The answer you got doesn't look like the other one, doesn't look like the one that Sage got or some other computer algebra system. This is why it's so important to know double angle identities, all right, when you're looking at that, because you realize they didn't write that down. And I agree with that. They probably shouldn't have used a double angle identity. They probably should have simplified that. And I'll probably update the notes now to reflect that. Thank you.